Welcome to EDU World Space.
In this problem, we have a cable that has a load that is a parabolic distribution somehow there. So we have a load that varies parabolically with the horizontal coordinate here. And the function is given by this, which is given in the problem. We can perform the integrals that are described in the book to get the function of y that describes the cable. And we get two constants of integration, and we get a quartic function here, or power of 4, because we need to integrate this twice. So we can find these two constants of integration if we set the origin here at the low point here, and it's also the midpoint because of the symmetry in the problem. So we have that y at 0 is 0, and then at plus or minus xb, which others is yb, and we can see that we have symmetry here, and well, as long as this C1 is 0, so we know actually from symmetry C1 needs to be 0, and we also find that C2 is 0 from these two conditions. Now we also have again, we can figure out that what this value is by looking at the slope at 0. I guess I didn't write that in here, but we should actually also have, say, the slope at 0 must be 0 because of symmetry. So that will give us this value also. So we can plug all this stuff back into y, and so now this is the function that describes the cable. We can figure out what the maximum tension is, where we know where the angle is a maximum here, and that again occurs at either one of these endpoints. So once we know this, we can take the derivative, find the slope, and find the slope at the end and take the inverse tangent of that to get the angle here. And then we can plug that into here, as long with this into here, and we plug in all our values that were given in the problem, and we wind up finding that the maximum tension is 9,280 pounds. And the angle that we get, the tangent of the angle that we have, if we take y prime and plug in x equals a, or x equals xa, we get the value 8/5 yb over xb. So the angle here, again, we can think about this as being the rise over the run. So opposite of that would be the angle of this triangle, but that's not what we need. We need the angle from this, and so that's a difference of 5/8. Just a way of looking at what this value is. I'm not sure what it gives us any physical insight, but that's what you can think of it as this being a factor that changes how the angle, if this were just a line, because this is now a curve.